And you do have a decent amount of things to keep you occupied today because we did a combo lesson. So you technically have two separate practices, but they're pretty short. Like I picked the best problems that are going to look most like what you'll be assessed on later. So do those, make sure that you are ready for the quiz tomorrow by doing those. And not only that, we have this Blooket review that will count for 10 extra credit assessment points. So when you do reach that 80% or higher, then please work on that, especially when and if we have visitors ever. Do something productive, and that's to prepare you for your quiz additionally tomorrow. What else? What else? What else? So today was really more when we have equations with our function notation. We spent a good amount of time when it was graphs. We spent a good amount of time when it's just situations what the input and output should be. Now you have what they say rules, but they're equations. All right, an input output table has each input plugged into an equation. So now when you have that equation, know whether or not the input is the number in question, so plug it in for the input, or whether or not they're giving you the output, so then you're solving for the input. The math itself is doable. We did it in unit 2. So if that's something you're struggling with, because what should be hard now is the function notation, then please reach out about the solving, because I can help you with the calculator. I can show you how to use it. At some point, it's like, we don't care if you know all your times tables. Like, we give you a calculator if you want. So if you are still struggling with solving for X, with simplifying, no matter what it looks like, let me know and I'll give you some strategies to calculators. So yeah, once our people observing come in, it'll probably be earlier than like the last 20 minutes when I normally check in and ask for requests. But whenever they start to come in is when I'm gonna offer requests for the practices. So any questions right now? All right, and again, make sure, especially when they are in here, that we're not off task in any way. Like they don't know that you reached 80% or higher or not. So don't be off task in any way when they are in here. Do have to get 80% or higher on the practice, and today it's 2 practices, so they're separate but they're both really short. And of course I can always delete one of your attempts so long as I think you're not just guessing. Okay, so if you do end up needing another attempt, just let me know and I'll delete one of them. But what questions do we have, if any, so far? Austin? First one on lesson 5. So if you are not quite there yet, or maybe you already did well in that one, then you can continue working quietly by yourself. But if you need help with the first one on lesson 5, you said, right? Then that is presented on the screen right now. So the cell phone plan from company C costs $10 per month, plus $15 per gigabyte for data use. The plan from company D costs $80 per month with unlimited data. Rule C gives the monthly cost in dollars of using G gigabytes of data on company C's plan. Rule D gives the monthly cost in dollars of using G gigabytes of data on company D's plan. So now you have to interpret the meaning of something that is in function notation. So break down that function notation that we've talked about. This first letter always tells you what about the function. No, so like the F. Anyone else? What does that very first letter tell us about the function? So it's the function's name. So like if it was function F, we call it F of X, right? They gave us C as our function name. So that is specifically for company C, right? So we're plugging into company C's plan. And our input is the 2, because what is it replacing? What's normally in the parentheses? The X, right? And it always defines your variables for you too. So when we are comparing the monthly costs in dollars and the amount of gigabytes of data used, what is the input? What is more independent, the gigabytes or the dollars? The gigabytes. So this 2 would be related to the gigabytes of data use. And then the 40, our output is what about the info? The cost. And I forgot to put an equal sign here, but you guys got it. All right, so it costs $40, not $2, to use 2 gigabytes of data then using Fancy. All right, that's what it tells you. So you just have to relate it back to what the X represents and what the Y represents. Then it says which is less, C of 4 or D of 4, and then a couple other inputs. And then lastly, we have an output and solving for the input. So it gives us our rules in writing. So we could make it an equation by translating it. So let's start with C. Let me put it over here so I don't have to scroll much. And we could use G for gigabytes. In fact, it wants us to, giving us something specific. And when we read that one, it costs $10 per month plus $15 per gigabyte of data use. So if this is supposed to be my cost per month, is that $10 being charged multiple times in 1 month? Or just once? Just once. So we're not going to multiply that by anything, because this is giving me my cost for the month, so that only happened once. But it is $15 per gigabyte of data use. So whenever we hear phrases like per every week, what math is that implying? When I say like each person, every week, multiplication. So in this case, we'd be multiplying 15 by however many gigabytes of data we use, which we don't know. That's what varies. And that combined, so combine means add, gives us the cost for company C, right? For company D, that one costs $80 per month with unlimited data. So that's similar to what we saw in the notes today. No matter how much they use, it costs $80. So what is my output going to be right here? Just 80. And now that we have the equations, we can compare them. So when it says which is less, C of 4 or D of 4, you have a few options. You could do the algebra. I'll show you both because we have 2 examples with different inputs. You could do the algebra, or you could use graphing technology. So we'll do the algebra first. Is that 4 an input or an output? It's an input. It's replacing the G. So anywhere that there's a G in my expression, I need to now put a 4. And then we can use your calculator to simplify that if you'd like. When I plug it into function D, for that one, you're plugging in the 4, right? It's still an input. Notice there's no other G to plug it into over here. So really it's just going to equate. So no matter how much they use, it's $80. We need to simplify this. So what is 15 times 4? Say a little louder. 60. 60 plus 10 is 70. So which one costs less? Company C or company D? Okay, we'll That is how you're doing that one, algebraically. But I mentioned you could also do it graphically, so it's up to you. If you have a lot of inputs to test, then you might want to do that. So I'll show you. And Desmos can read function notation so long as you put it in correctly. So that equation was 10 plus 15g. If you used a function notation, it automatically knows what's in the parentheses as the input. And this whole unit right here is your output. So it's like your X and Y. And then the other one was D of G equals 80. So when we have an input of 5 that we're wanting to test out, with Desmos, you can drag and click until it's like exactly that. So there's pros and cons to each method depending on what it is. So for company C, it's 85. Everyone see that written as a coordinate? For company D, it's $80 no matter what. So which one's cheaper, C or D? For that one, D. Okay. For this last part, is that 130 an input or an output? It's an output. So don't try to plug it in for G. You know it's not G because you can still see the G. Plug it into function C. And we're plugging it here. Like this whole unit equals 130. So we're replacing that with 130. And this time solving for, which we did in unit 2. So it's not the algebra of it that is the new skill. It's just the function of it. Whenever you're solving for a variable, what do you always get rid of first? What is farther? So would that be the 15 or the 10? You sure that's farther? The 10 is farther, right? So we have to get rid of that first. How do I cancel out the 10? Whatever you do on one side. And I get 120 equals 15g. Opposite of multiplying 15 would be, and whatever you do on one side. Good. And then I get whatever that equals. I need to later. 120 divided by 15 is 100. What'd you say? That sounds a bit too high. My options are 8 and 10. Okay. I'm still gonna double check, but I believe it's 8 because if it was a 10, it would not, that would not work out, but you're right. Okay, so that's that one. Let me make sure the key is completely right. And it is. All right, any other questions from either practice? Austin? Number 4 on practice 5. Okay, so function P gives a perimeter of an equilateral triangle of side length S. Is represented by this equation. And we're saying what T of S equals 60 means. And finding a value of S to make it true. So I can understand, like, if you don't remember your geometry, then some of this might be really, like, hard to figure out. How do you find perimeter of any shape? You add all the sides. To make that look more like a word. You add all the sides to find the perimeter. What do we know about triangles? They have 3 sides. What do we know about equilateral triangles? No, so it's still a triangle, it still only has 3 sides. but an equilateral triangle has sides of equal length. So if one of my side lengths is S, so one of my other side lengths, that's not a 5, that's an S. And that's why this is the equation, because instead of just doing S plus S plus S, 3 times S would be the same thing. Okay, just so you know. So when it says P of S equals 60, you have to interpret what our input and output represented. So what is S representing? It is. What about in this specific situation? The side length of this triangle. I'm just going to shorten it to side. The output, so what it's equal to, will give me the perimeter of the triangle. So when I'm interpreting this, is this 60 a side length or the perimeter? Side length or perimeter? Perimeter, because it's in the area where it would be the output. So I guess to answer this now, the perimeter of an equilateral triangle of a side length is 6. Okay, I don't know. The phrasing of that is, I don't know if it wants the S, but 60 is the perimeter of that solution. Find the value of S to make the equation true. You do have a couple of options. You could plug in both. But if this is my given rule, I should be able to plug in my perimeter here and solve for the S. And again, that's an S, not a sign. What's opposite of multiplying by 3? I want to redo on one side. And what's 60 divided by 3? So that is why it is. All right, questions on that? That is right, by the way. Yes? On lesson 5? Or which one? Lesson 4. Number 3, lesson 4. All right, an equilateral triangle has 3 sides of equal length. Function P gives the perimeter of an equilateral triangle a side length S. Find P of 2, P of 10, and P of S. So let's start with this one. They often will like give you numbers and you guys can solve them really well, but then when they give you a variable, you get kind of like these, I don't know what you call it. You get confused. So this one is basically making a rule to define the perimeter of an equilateral triangle, which we actually just talked about in that other problem. How would you find the perimeter of an equilateral? Would you do 3S or S plus 3? 3S. That will make it easier, I think, to find the rest. Because otherwise, what you have to do, like if this was my side length, you have to envision a triangle with side length of 2, which when you add that all up is 6. Well, not 3, 6. All right, or if you know how to make the equation, plug it into the equation for the S and solve. What's 3 times 10? So yeah, if you're able to make the equation right off the bat, great. Then all you have to do is plug it in. Otherwise, like you had to know how to find perimeter of an equilateral triangle, and given a side length, know that you're just adding it by itself 3 times. Other questions? Any practice? The old ones? Yeah. Oh, lesson 5. Lesson 5. Lesson 5. Okay. W gives the weight of a puppy in pounds as a function of its age T in months. Complete each sentence to describe the meaning of the given statement. Whenever they really define it with the phrase function of, I know whatever follows it is going to be my input. I mean, you might already know because we talked about like how time is almost always the input. Just like whenever they use the phrase function of, that's like a big giveaway. I know that if this was graphed, its age in months would go here on the X. And the weight of the puppy in pounds would go on the Y. And that, I think, makes it even easier to interpret it after that. All right, so when it says W of 2 equals 5, is that 2 going to be months or numbers? Is it replacing an X or a Y? So yes, we are going to use the phrase months for it then. And then is that 5 pounds or months? So when we're interpreting it, we would say at 2 months, the puppy weighed 5 pounds. Then when we have other phrases like this, W of 6 greater than W of 4, we're saying the puppy may weigh more at what month when the opening faces? Is it the bigger number that it faces or the smaller one? So did it weigh more at 4 months or 6 months? Then at 4 months. Good. Again, these are inputs. Now we're using an equal sign so that you know what equal signs tell us. The puppy's weight was blank at 12 months and 15 months of age. So the same or different? That's all for that one. Questions on this one? Questions on others? Any? Could be old one. Five. Oh. All right, well, if you have any others, let me know. So yeah, 80% or higher, and you do have that book it if you want to get a really good score in math lab or just on the quiz in general, if you know this.